Ladies and gentlemen, esteemed guests and fellow scholars, good afternoon. I, Lavleen Sharma,
I, Astha Chaturvedi,
and it's honor to address you today as we convey for the 5th International Conference on Recent Developments in Control, Automation and Power Engineering, RDCAPE 2023. On the behalf of the organizing committee, I extend a warm and a heartfelt welcome to each one of you. This conference serves as a hub of knowledge and innovation, gathering brilliant minds from around the world to exchange ideas, explore cutting edge research, and collaborate on solutions to our most pressing challenges.
Our focus today is the first technical session centered on control systems and applications, and we are privileged to have two esteemed session chairpersons. Dr. Amit Kumar Singh, Assistant Professor, Department of Instrumentation and Control, NIT Jalandhar. Dr. Vedatri Maulik, Assistant Professor, Amity Institute of Technology, Amity University, Uttar Pradesh, Noida. Allow me the privilege of introducing our session chairperson, Dr. Amit Kumar Singh, whose remarkable profile reflects his dedication to this field. Dr. Amit Kumar Singh is an assistant professor in the Department of Instrumentation and Control Engineering at NIT Jalandhar. He earned his MTech degree with a coveted gold medal from NIT Kurukshetra in Control Systems in 2009, a testament to his academic excellence. His dedication to research led him to pursue a PhD from IIT Roorkee, which he successfully obtained in 2015. With over a decade of experience spanning both academia and industry, he is a prolific researcher, having authored more than 40 papers published in esteemed journals and presented at renowned conferences. Dr. Singh's research interests span a wide range of topics, including process control, meta-heuristic optimization in various control applications, renewable energy, and soft computing applications in control engineering.
We are privileged to have Dr. Amit Kumar Singh with us, and we eagerly anticipate him sharing a few words of wisdom and insights for this session. Sir, please.
Thank you. Thank you very much. Thank you, the team of the conference, organizing team, Dibya ma'am, and all other related authorities. Thank you very much for the invitation. I'm feeling privileged to connect online, though I want to join physically, but due to some problems, I was not there. So,
sorry to interrupt you. Can you please turn on your video?
I'm getting.
Sir, can you please turn on your video if possible for you? Video, sir.
Actually, my webcam is not working. Some problem is there.
Okay, sir. No issue. You continue.
Okay. So my audio is available or not?
Yes, sir.
We are getting?
Yes, sir. We can hear you.
Okay. Okay, then I hope the participants will be benefited from this conference and will get the novel ideas from the different approaches to control system and applications. Thank you again.
Thank you, sir, for sharing your profound knowledge and valuable information. I now hand over the session to the session chairperson, Dr. Amit Kumar Singh and Dr. Vedatri Maulik, who will guide us through this session.
Sir, would you invite the presenters, or we will invite?
I think you can invite, and based on that, I will evaluate.
Okay, sir. No issue.
We have the paper ID 280. The topic being comparative performance analysis of PV system in island mode using MPPT, fuzzy logic controller, and perturb and observe algorithm, presented by Sagnik Ghosh. Please, could you...
Good afternoon, everyone. Am I audible?
Yes,
Yes.
sir.
Okay. I have to share my screen. Acha, host has disabled the participant screen sharing. Can you please enable it?
Done, sir.
Good afternoon, everyone. My name is Shagni Ghosh. I have completed my MTech in Power Electronics and Drive from NIT Kurukshetra, and I am currently working in AppSpan Analytics as a data engineer. Today, I am going to represent my paper on a comparative performance analysis of PV system in island mode under MPPT fuzzy logic controller and part of observed algorithm. So, this is the so at first uh, we uh, see that in PV systems under different irradiances when we apply certain normal uh, controlling logics, then the amount of power which we extract from the PV array is very less. So to increase the efficiency, we can use some advanced machine learning algorithms like fuzzy logic and part of other algorithms to increase the duty cycle so that we can uh, extract more amount of power from the PV system. The PV system, when plotted against voltage and current characteristics, shows a non-linear characteristic under different irradiance. So, the amount of power voltage which we extract from PV system is very less. So, to increase it, we use the boost controller, and the duty cycle of this boost controller can be controlled by the fuzzy logic and part of the algorithm to attain.
Mr. Sagnik, your voice is breaking. It's not coming properly.
Hello. Actually, I am. Uh, Actually, I have connected it with my phone network, and this is the network in this zone. So, hello. Am I audible now properly?
Yes.
Okay. I'm sorry for the inconvenience, but this is this is how the network coming. I'm sorry
Sir,
for
he's
that.
audible to us. Dr. Amit, we can actually hear his voice. Please continue.
Okay. So in this paper, I have represented a comparative performance analysis among the two algorithms in under island mode with a resistive load range to observe which gives us a better response. So this is the related work which I have seen, which has been done on this field beforehand, and in observing all these related works, by uh, by observing these related works, I am able to obtain that the fuzzy logic the duty cycle which has been obtained by fuzzy logic can be improved by margin, so that we can extract more power from the normal previous given fuzzy logic algorithms, and it will also give a better results than the part of observed algorithm. So the research gap in this shows that there already exists a conventional part of observer and incremental conductance for establishing the maximum power point tracking algorithm, but performance has to be improved in this field. The fuzzy logic controller is one of the best solutions available to us in order to give us a better understanding and a better efficiency than in respect of power in this aspect. So we use a boost converter to in this circuit to improve the voltage level in order to get the highest possible output power and under different irradiance. These are the algorithms of the part of observed methods and the fuzzy logic which I have been used for making the port and controlling the duty cycle of the power converter which has been used in the circuit. This is the block diagram of the circuit to obtain the MPPT. We use a photovoltaic solar panel where we obtain take the input voltage and the output input current at different irradiances, and then by using the two algorithms we conclude a duty cycle which will be fed to the power boost converter switch, so that we can obtain a particular uh, voltage and power in the outer output side. The output side has been is a resistive load which has been used to measure the power obtained. So the system parameters which I have taken are shown below. The resistive load which I have used is 23 ohms, and the capacitor is 1734 mu farad. The inductor which has been used here in this circuit is 162 millihet. This is the simulation results which I have obtained at different irradiances. I have taken three irradiances to come for a comparative analysis, that is 600, 700 and 800 watt per meter square. So this is the result of the power output and the voltage output at 600 watt per meter square irradiances using fuzzy logic controller. And this is the 700 watt per meter square irradiance readings. Similarly, I have obtained the 800 watt per meter square results. Uh, and here in this graph, I have shown the change in output power and voltage at varying irradiance. It is seen that when the output power irradiance changes, the output power also changes, and the voltage obtained also changes in this resistive load circuit. Similarly, I have taken the part of an observed algorithm readings at 600 watt per meter square irradiance and 700. This is value is obtained, and even in 800 irradiance. So when we even under the similar condition of changing irradiances, when we put this part of an observed algorithm, we see that the power output and the voltage output also changes with the change of irradiance in the input side. This is the power comparative table which I have obtained at 800 irradiance. The input power which has been obtained is 192 and the output power is 186. So the overall efficiency is coming at 96.83 for the fuzzy logic. And similarly, when when the irradiance is increasing, the efficiency is also getting better, and the voltage obtained is also in the higher side. Similarly, when we see the power comparison table for the part of an observed algorithm logic, the similar nature is shown, but the efficiency is a slightly delayed, slightly little than that of the fuzzy logic algorithm. And this is because the voltage obtained in the part of observed is also less in comparative to the fuzzy logic algorithm at the similar irradiance. So after comparing the all the parameters, after comparing the two logics under similar parametric conditions, it is obtained that the fuzzy logic extracts much more power and voltage, and the efficiency of the overall efficiency of the fuzzy logic controller is 2% more than the part of the algorithm, and this is because of the converter parameters introduced in this circuit. The conclusion of this states that this circuit has been designed for MPPT analysis under resistive load condition, and as a result, the irradiances changes and the power extracted also changes, and the output voltage also alters because of the change of irradiance. The variable voltage can also be utilized for various purposes, and if it can be made constant, then the power extracted at different irradiance can be used for numerous purposes. Uh, uh, especially for charging of electric vehicles, batteries of electric vehicles, and other storage of energy can be done by using cells, so that we can this power can be utilized for other purposes, uh, for uh, for sending it to places where there is a power cut, or when there is night, we can use this uh, stored energy to supply power in those areas where light is not available at that time. These are the references of this A, which of the papers I have taken, uh, and thank you for the presentation. Any questions?
So, Mr. Zagnik,
Yes, sir.
just tell me why you choose fuzzy logic for this purpose. There are various latest algorithms are there. For example, some meta-heuristic approaches are there. So you may use that algorithms, and surely you will get the better results.
Uh, Sir, the metallurgical approaches which are being used nowadays is also giving a output, but the fuzzy logic algorithm I have utilized here is much efficient than the fuzzy logic algorithms which has been previously been used, because of the change of the ranges which I have taken by studying all the previous papers and journals for this purpose. And in today's world, most of the things which are being most of the electrical appliances are going to use AI and machine learning algorithms to do their work. In earlier times, like
No,
normal
but the actual problem with the fuzzy is that you have to choose the parameters manually initially. Okay.
yes, yes,
How many
yes.
linguistic variables you have taken here?
What, sir? Can you repeat
How
that
many
question?
linguistic variable you select?
I chose, sir, C and L. I have obtained by by considering uh, the frequencies, and the R also has been fixed at 20. And according to that, I got the C and L values, and then I had done the MATLAB simulation.
So it is my suggestion to utilize some machine learning methods with fuzzy.
Yes,
Then you will get better results. Okay.
yes, sir. Of course,
Okay.
I will.
Okay. Okay. So that's it from my side.
Any more questions?
Are there any queries from participants? Next paper ID 289.
Excuse me, I want I have a little request to the presenter. I have another paper today in this session. It's ID number 413. You can see.
You can continue.
If it is possible, I can continue and like
Continue
complete.
right now.
Okay, okay. Thank you. Now I'm going to present my second paper, which is on the
Sorry to
title of
interrupt.
perform.
Excuse me, sorry to interrupt.
Okay,
Can you put your slides in presentation mode?
okay, okay. Thank you. Uh, Now I am going to present my second paper, performance analysis of PV system in island mode based on fuzzy logic algorithm and part of algorithm with ESS, energy storage system. So in this paper, we have seen that part of like in the previous paper, we have shown that the fuzzy logic algorithm and part of also we have made a comparative analysis between the two algorithms, and we have obtained a certain output based on that. And by comparing this output, we have observed that when we use a resistive load, the energy which is obtained in the output side is also varying with the uh, input irradiance. So this energy can be utilized if we can stabilize the voltage at a certain level for change of irradiance. So for this purpose, uh, 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 I have first compared the two algorithms and have shown that the fuzzy logic algorithm is getting a better result than the part of observed algorithm. Now this circuit which has a resistive load will show this variable change in voltage in the output side at different irradiance, and this can be solved by using a PI controller uh, in the output part, which will be fed to a battery to store the energy. This energy stored can be utilized by electric vehicles and can be used also for putting up charging stations. This is the block diagram of the circuit which I have made by improving the MPPT algorithms. The PI controller, a bidirectional converter has been used across the resistive load, which will be feeding to the which will be connected to the battery, and the battery input output and the voltage and the current reading will be fed to the PI controller, which will automatically control the duty cycle of the bidirectional converter for obtaining a constant voltage in the output side at variable irradiance. The this is the voltage, this is the irradiance which I have taken to show this process. So at first the 300, this is the change of irradiance with respect to time. Time period of 4 seconds is taken here. So at first the voltage is changing from 300 watt per meter to 400, and then increasing to 450 watt per meter square, and then decreasing to 400. Similarly, if we can see, the voltage is in the input side is also varying a little bit, and the current input current is also varying. The output current shown will also be changing because of the duty cycle in the in input side and duty cycle of the converters. So this is the output of the battery side which we have obtained when we use the bidirectional converter. 45.4 volt constant voltage will be obtained in the output side in the of the battery. And if you can see in the second B graph, we have shown a change in load voltage and reference voltage of 45.4 volts in there. And sorry for 1 second. Sorry, the output side of the in the B graph, we have shown the voltage will be obtained in the resistive side when we are connecting a bidirectional converter in the output part of the battery. So a 48 volt reading will be obtained in the resistive load, across the resistive load, uh, and it is the red line shows that 48 volt marker, and and if you will observe, a constant voltage of 48 volts is obtained in the output side of resistor. If you can see the SOCs, at first when the irradiance is in 300 volts, 300 watt per meter square, the battery is discharging, and this also and when it is increased to 400 watt per meter square, the battery starts charging, and when the irradiance increases, the rate of charging also increases, and then stabilizes when it's reached 400 watt per meter square irradiance. And the battery current is also changing. At first, when the battery is discharging, the battery current is in positive side, and when the battery starts charging, the battery currents become negative and is in the negative side. So the future scope of this is that the system can be used for G2G and V2G operational mode conditions. The charging time has to be reduced by the proper planning, and using efficient models of charging station can be designed for extracting the optimal power at least time. Various developments have been made for making this output system to be more powerful, and if another automated system can be made in the output side to feed for the bidirectional converter, the output can move, in the battery side can be extracted, and the efficiency will also increase. The output values of the fuzzy logic can be used for training and testing data for ANN model of tracking MPPT algorithm. And in conclusion, it is seen that at first the fuzzy logic is one of the most efficient models when we are comparing it with the normal incremental conductance method or PI controller method, or even the part of algorithm. The system which is designed to track MPPP and various irradiances, and this and we have also achieved a model where we can stabilize the output voltage so that we can use it for uh, battery we can use it for other purposes, especially for charging of electric vehicles, and also sending this electric power to for other purposes in places where we can there is no supply of energy. Constant 48 volt is obtained at the resistive part when we are using this bidirectional converter, and a PI controller has been used for these purposes. And these are the reference which I have taken for solving this purpose. And thank you. Is any question?
So, Sagnik,
Yes.
you said that you utilize a PI controller for
Yes.
converter
For the
duty cycle, okay?
Yeah, for the bidirectional part.
Bidirectional duty cycle, na? Duty cycle
Yes.
control.
Yes.
So, in that case, how you tune the parameters of PI?
Sir, at first, I tuned it by taking the uh, KP value and KI value, and then I
How
use
you
the
how
auto tune.
you how you get
Like
the values of P and I?
at
KP
first,
and
sir, I
KI.
used the KPI. I made the circuit and used the auto tuning purpose, and then from
No,
there,
no, well, that is part of tool, but you should know,
uh,
na, what is that method
yes, yes, sir, Ziegler Nicholas method.
in
Uh,
auto tuning?
Sir, no, not in auto tuning. I used the auto tuning, and then I slowly tuned it by calculating the range where the value was.
When you auto tune, then there is uh, basically no requirement to utilize any other method. I want to know
Yes,
what is the method to utilize to get the optimal parameters of KP and KI.
uh, optimal. Sir, actually, in theoretical, we use Ziegler-Nicholas method
No,
in
that is very
obtaining.
old method, and actually Ziegler-Nicholas is utilized to get the approximate values of
Yes, sir.
the parameters, and then you have to fine tune the values. Otherwise, the results will not be uh, in desired form.
Sir, I did this iteration, and and I use this Ziegler-Nicholas method, and then I used put the values there, and I used that iterations to make to obtain a solution
Actually,
where
one thing, just listen. My concern is that in duty cycle, actually, it is very important to get the accurate duty cycle,
yes,
on-off
sir.
timing. Otherwise, you will get the wrong results, and the
Yes, sir.
converter will not work in desired manner. Okay, so
Yes.
kindly go through it and try
I
to
will always do.
get the optimal parameters of PI. Okay.
Okay, sir.
Okay. Okay.
Thank you. Any more questions?
Next, paper ID 289, turning of PI controller using genetic algorithm and differential algorithms for closed loop single switch semi-quadratic buck converter by Devadi Sen.
Hello, am I audible?
Yes, you are audible.
Just a second, just a second. Is my screen visible?
Yeah, visible. Please put your slides in the presentation mode.
Just okay. Just let me start. So, hello everyone. I am Devadip Sen. I just completed my masters in control systems from NIT Kurukshetra. So today I am going to give my presentation on tuning of PI controller using genetic algorithm and differential algorithm for closed loop single semi-quadratic buck converter. These are the contents of my work that I've done. So coming to the first slide, that is the introduction. So the discipline of power electronics is now paying increasing attention to the DC to DC converter. When due to the increasing complexity of the electrical circuits, controlling a power converter in a nonlinear control any power converter is a nonlinear control problem as the state space equations change when the switch is turned on and when the switch is turned off. Since manual tuning of PI, conventional tuning techniques have been used, such as genetic algorithm and differential evolution. So, reasons for choosing algorithms for tuning PI. So, first point is optimization capability. The evolution algorithms such as genetic algorithm and differential evolution excel in solving problems, optimization problems. The tuning of PI controller involves finding optimal values for proportional and integral gains that minimize the specific performance criteria. So coming to the second point, no explicit model is required. So in case of other artificially intelligent controllers, we require the information regarding the model. So in case of tuning of tuning such complex systems, we don't require any prior model information. We can simply use the evolutionary algorithm. We do not. So coming to the next point, that is handling nonlinear systems. So many real world systems exhibit nonlinear behavior, making the control design process more challenging. Evolutionary algorithms are well suited for handling nonlinear systems since they can effectively search for solution in complex and nonlinear solution spaces. Coming to the last point, that is the computational efficiency. The solution space of tuning PI controller can be large, especially when considering multiple controller gains and potential parameter interactions. Evolutionary algorithms provide a systematic and efficient approach to explore the space and converge to a good solution without exhaustively evaluating every possible combination. So coming to the related work, so these are the related work that I've gone through, which has helped me complete my this paper. So these are the related work. So coming to the challenges that I have faced. In a standard buck converter, the output voltage is linearly proportional to the duty cycle of the switching signal. However, in a single switch semi-quadratic buck converter, the relationship between duty cycle and the output voltage is linear for a small input voltage and quadratic for a large input voltage. As the name suggests, semi-quadratic. So that is the reason mainly we cannot use standard buck converters. This non-linearity complicates the control design, as traditional linear control techniques may not be directly applicable. The switching action itself introduces non-linearities. The abrupt switching transitions can cause discontinuities in the system behavior. The inductor capacitor used in the buck converter can exhibit nonlinear characteristics due to the presence of parasitic resistance. Here, the parasitic resistance considered is 0.1 ohm in case of my analysis. So this is the circuit diagram of the single switch semi-quadratic buck converter. As we can see, there are multiple diodes and capacitors. So it's a highly nonlinear system to control. So closed loop control strategies have been used to control the buck converter, this buck converter. So coming to the future, so this is the basically the workflow that has been followed for tuning the PI controller for both the cases, that is genetic algorithm and the differential evolution algorithm. So coming to the untuned response, this is the response that is not tuned. So it has been improved in the why after tuning it with genetic algorithm. So coming to the differential evolution algorithm, we can clearly see that the response is much better than the genetic algorithm. So coming to the result and analysis, it can be clearly seen from the response that the response of genetic algorithm in the figure below is lower than the differential algorithm. It happens due to the mutation strategy that allows DE to explore the parameter space more efficiently and effectively than mutation operators used in GA. DE typically requires fitness evaluations compared to GA. DE has a reputation for faster convergence to optimal solution, and DE has fewer parameters to tune as compared to GA. The red color in both the graphs shows the response of the tuning algorithms, while the blue color shows the untuned PI response. The table below shows the performance results. So we can clearly see that both the algorithms had no overshoot, no oscillations present, but the main difference was that DE gave a faster response, and GE gave a bit slower response. So coming to the application, many components like microprocessor sensors require stable and precise low voltage to operate correctly. Electric vehicles have batteries to supply to various electrical components in vehicle. The battery voltage needs to be stepped down. Maintaining a low constant voltage helps us to protect the batteries and improve their lifespan. Electric vehicles experience dynamic load changes during acceleration and deceleration. So this control strategy will help them respond quickly to load transients, as I discussed in DE algorithm. So it's the best suited for this purpose. Coming to the conclusion, the thesis presents, no, sorry, not the thesis. This paper presents us the control strategies for highly dynamic single switch buck converter. The mathematical modeling and simulations are done in MATLAB and Simulink. The untuned PI controller are used, which give better response with less overshoot and faster settling time. But on tuning the PI controller with the evolutionary algorithms, the results of PI were improved to a great extent. The voltage and current ripples were kept extremely low. Further research can also be done on various other tuning algorithms, and further research can also be done on various other controllers and various fields where PI has been used. So these are my references. Finally, thank you.
Devadeep,
Yes, sir.
I have two questions. The first
Yes,
one is, why you compare the results of these methods with the untuned PI? What is the meaning of that?
sir. Actually, I wanted to show that the means just the result that while it is not tuned, it's performing better. Just a comparison. Nothing
No,
much.
untuned means you have not utilized any method.
Yes,
Just
sir.
put the random values.
Yeah, it's a random initialization.
Oh, this is not the way to compare the results of any controller with any other. You have to utilize some standard method, or we can say some conventional method. Right?
Yes, sir. I mentioned
Then you can
conventional.
compare. So this is one of the question. And another one, why you
Yes.
choose PI? Why not PID?
Sir, actually, PI is more used in industries. So
How you can say that PID controller is utilized? It might be happen that D value is 0. So might be 0.
yes,
Okay.
sir. D value is 0. Yes.
Why D is 0?
Sir, because the D part means increases the noise. If any noise is present in the system, then it will get amplified. The high
But
frequencies.
we generally utilize low pass filters with PID.
Yes, sir. But sir,
Okay.
mainly in industries we use PI controllers. Most of the
that is
researches
not
are done.
that is not the answer. Okay. Okay, just go through it.
I
Okay, sir.
have one question.
Yes.
Can you define the optimization problem once? Like what is your objective function? What are the constraints? What are the
Yes. For in case of genetic algorithm, the chromosomes that the initial population that I have considered is 150. So, and the chromosome representation used is double vector. The fitness function that has been used is ITAE, and the evaluation and the for KP and KI values, it has been considered from 0 to 1500. Both are in between 0 and 1500.
So
And the selection is based.
Choose these boundaries.
What?
How did you choose these boundaries?
Actually, according to the previous reference where I have taken, mainly, so there they had mainly mentioned those boundaries, so that has been taken into consideration.
Okay, thank you.
Yes.
Thank you, sir. Next paper ID 292, Unwilling Motor Control Techniques, a comparative study of sliding mode control, SMC, proportional integral derivative, and fuzzy control, presented by Priyam Srivastav.
Yeah, hello. Am I audible?
Yes, you are audible.
Yeah. So I'm just sharing my screen. Yeah, is it visible?
Yes, it is visible.
Okay.
Please put it in presentation mode.
Yeah. So, first of all, good afternoon, all. Thank you for giving me this opportunity. I am Priyam Srivastava. I am from NIT Kurukshetra and my specialization in control system. So I'm just giving presentation on the motor control techniques, a comparative study of sliding mode, proportional integral, and fuzzy control. Just introduction. Yeah. So DC motor, as I worked in industries, so there I saw many of the vehicles and electric vehicles and lot of the things like home appliance, there was using DC motor control. So that's why I choose a DC motor control, and here I want to control my speed. So here I just use three methods: sliding mode control, and PID, and fuzzy control. So first of all, I show the DC motor model how I took. So as it is visible, I just use this DC motor, and after that I use the transfer function to control my DC motor. So first of all, I just derive transfer function of this DC motor. After that, I just go to design my sliding mode control. For sliding mode control, first of all, I have to convert my DC motor control in controllable space form. After that, I just choose my surface equation this, and for this I just want to some equilibrium condition. I want one surface, and on that one equilibrium condition, on that my system will be stable. So that's why I just use Lobneau function. So Lobneau function, I just use this v is equal to half s square, and there whatever just I choose lambda 1 and lambda 2, that should be fulfill Harvey's condition. After that, just I just fulfill the condition, and after that I just got my s, and s derivative is less than 0. For less than 0, I have to derive one controller. So I just got u is equal to zl by kt and lambda 1 e dot plus lambda 2 rl plus bz. This I got controller. And for my transfer function DC motor, I use these values and this signum function. Yeah, and after that I just use my fuzzy control. Basically just my focus was on the sliding mode control, and so in this fuzzy motor control I use Mamdani model, and here I just give speed error and derivative of speed error input. Yeah, and after that I use PID control. Inside the PID control I use Ziegler-Nicholas method. First of all I just used I set KP value. After that I just check what's the response of my graph, and according to that I just started to increase my KP values, and again I just enter the KD and KI values. So I just use this this table, like how to choose PI value, KU by 2, and this all. And I got this my simulation result. From simulation result, I just got like a fuzzy control is behaving like a medium between the SMC and the PID. Like PID control have less rise time, and SMC control have less shattering effect, and also it is not prone to that much distortion. But only one thing is like it is not, it have some tracking error. So as we can see, this is the blue line, this is the SMC output. So it is unable to track, but it has approx 0 overshoot. So that's why this is very good. And this is the PID control, very less rise time compared to all. And this fuzzy control, this green line, it's behaving between these two. Yeah. So if I just compare my everything, so what about overshoot and rise time? So this is the table there I got, and this is the SMC control signal, and this is the fuzzy control signals. Yeah. So when I just saw the conclusion, so I just got in the SMC less shattering effect, and in fuzzy is just like behaving moderate. It just like it have very less undershoot. If I just compare in these three methods, fuzzy is more good in less undershoot. Yeah, and futuristic, as I told, DC motor is very wide to use, like home appliance and new technologies, home appliance, electric vehicles, everything. And if we want some adaptation, then sure we will go to fuzzy logic control. And if we have not very much non-linearities, lot of distortion, then we will prefer sliding mode control. And if we want our model to be simple, so and very less rise time and complexity very less, so we will go to PID control. So yeah, that's all from my side. Thank you. These references I took.
Priyam,
Yes.
what is the set point of your motor?
Yeah, set point motor up, I just use one. It's unit.
One of what? Speed?
Yeah, like speed I was given 1 meter per second. Just
So you maintain the speed at 1 meter per second only.
Yeah, I just using this tracking. I just want to choose. Yeah,
So what will happen if you change the set point?
yeah. I
It is
check
not
also.
practical to use 1 meter per second in case of motor.
Okay. So I change the speed
If you
many
increase
times.
or decrease the set point, what will happen?
Yeah, it was tracking, but little bit distortion.
No, but you have taken the constant set point.
Yeah, I
Uh,
do constant set point.
you can analyze only when you utilize variable set point with variable with time. Any set point variable with time, then you can check whether your controller tracking the set point properly or not.
Okay.
And other question is that there are various comparative indices you utilize here: rise time, overshoot, undershoot, settling time. Okay, so which one is more appropriate for your application, or
For
more
me,
important, we can say?
yeah. For me, sliding mode control is more appropriate because it's just
No,
showing
no, I
zero.
am not talking about controller.
Yeah.
I am talking about these comparative indices.
Okay.
Comparative indices means these rise time, settling time, or
Okay.
slew rate,
Yeah, sure.
or
So
okay. So which one is in priority in this application?
overshoot.
Overshoot.
Yeah.
So what about settling time?
Uh, I just prefer in this overshoot.
But important term you miss here, that is the steady state error.
Okay. Yeah, that's why this is compared to slew rate, because in slew rate it is more prone to distortion. So I just check slew rate in these things like distortion and everything.
No, but by utilizing slew rate, how you can say that is what is the steady state error?
Steady state I can't utilize, but using the settling time I can see like it is tracking or not. If settling time is less,
No. What is steady state error?
yeah, it's like desired, and whatever we are getting in the difference, that is error. So
That is very important. If you are
yeah,
giving some set point, that it is very important to achieve that set point. You have to
uh,
check whether steady state error is within the limit, plus minus 2% or 5%, whatever you choose.
okay.
Okay.
Yeah, sure.
Okay.
Yeah, thank you. Yeah, any more question?
No, thank you, ma'am. Next paper ID 301, design and implementation of an automated conveyor belt system with speed control, size sortation, and IoT data publication. Presented by Devraj Gautam.
Is it visible, ma'am?
Yes, it is visible. Put your slides in presentation mode.
Yeah, ma'am.
It is on the right hand side bottom corner.
Just a minute. It's fine.
Show first slide.
Is it okay, ma'am?
Please start.
Good afternoon to everyone. My name is Devraj Gautam. and my affiliation is Dr. from the Dr. Akhilesh Dasgupta Institute of Technology and Management. May I audible, ma'am?
Yeah, you are audible.
Okay, ma'am. And my paper ID is 301. Paper title is Design and Implementation of an Automated Conveyor Belt System with the Speed Control, Size Sortation, and IoT Data Publication. And first of all, I would like to thank the organizing committee who has provided such kind of the platform of the 5th International Conference on Recent Development in Control, Automation, and Power Engineering, RDCAP 2023. And these are some parts of the table of contents in which through which I would like to express my presentation. Abstract first of all, and after that introduction and related work objectives, designing and implementations, proposed framework of the system. After that, then result and discussion, conclusion, future scope and references. So first of all, I would like to discuss. About the abstract part. In this paper, basically the proposed an automated conveyor belt system that is designed to transport objects from one location to another. This system includes a speed control feature for the user, as well as we use the camera as well that uses an open CPU control area to determine the size of the object, passing through the conveyor belt and bounding box to determine if they are in the desired size. Otherwise, it will stop the process and it will show the response that your size is beyond the limit like this. So furthermore, the system leverage the power of the internet, IoT basically. And so that's why this system is IoT based conveyor belt and speed control system. And the response will be in the things speak app, which is the part of the IoT platform. Discussion the system architecture, the integration of the speed control and the size rotation mechanism. Experimental results demonstrate the effectiveness of the proposed system in enhancing productivity, reducing error, and providing valuable insight for the process optimization. In the introduction part, first the conveyor belt are basically, as you know, they're basically used in the most of the industry to convey the process through one place to another place to like for this purpose. The mining industry, for just example, the mining industry, for example, utilizing long distance, large scale conveyor belt for the transportation of the heavy machinery and equipment over long distance. That's why the manufacturing industry time is a critical factor, and delay in production can have a significant impact on the revenue generated. So in warehouse also the conveyor belt is the main part through which we can carry the items from one place to another place and sorting the. That's why the conveyor belt is very important. And from this warehouse, I opt the idea. This will be the our aim. So we have to do some work on this. That's why I am choose this option. The modern conveyor belt, basically, which we are in updated version of the IoT, in initial from the 1892 for the transportation of the coal, assembly lines utilizing conveyor belt were first introduced by the Henry Ford in 1930. Since then, conveyor belt having undergone various advancements, and currently the industry is at the threshold of another strategic changes. This integration allows us to publish real-time data to the things with the IoT platform. That's why we can access remotely the actual process of the conveyor belt. And these are some related work which have already have been done by some other researchers and some other persons. So, recent study focus on the integration of the Raspberry Pi OpenCV and image processing method have drawn a lot of attention to the field of object detection and separation. Numerous researchers have looked into how these technology might be used to create novel solutions for such applications. And approach for object separation and detection using Raspberry Pi was put forth by Vellum et al. 2018. And in 2015, the object, another paper by the object of different size are passed to the sensor and object having specified size is shorted. So in 2015 already have work has been done to extract the size of the different size and to pass to the sensor and object having specified size is shorted.
Mr. Devraj, kindly present your work. Okay, note literature review required. Kindly go to your
okay, sir. So at the end of the yes, sir. So I have passed the related work, and this one is the conclusion of the related work. Our research paper presented a novel and cost-effective automated conveyor belt system with integrated speed control. So first, our work is to design a conveyor belt. After that, second thing is to control the speed of the conveyor belt. And third thing is to place a tripod stand onto the conveyor belt and place a camera with the tripod stand. That camera will find out the contour area of the object which is to be placed on the conveyor belt, and that on the basis of that we will find out the information. Okay, what is the actual size of the object which is placed on the conveyor belt? That data will be detected by the after data processing will be given to the Raspberry Pi, and Raspberry Pi will show the data in the display unit, LCD display, as well as that display on the thing speaker with the help of IoT platform. So these are some objectives to design and develop a cost-effective advanced, which I have just discussed. Design a cost-effective advanced electric material handling system. So so that's why labor requirement is, if the conveyor belt is properly designed and controlled with the speed control and etc. That's why labor requirement is very less. Integrate with the speed control features in the conveyor belt system and incorporate object detection and classification capability. So remotely access of the conveyor belt system is using the thin speaker. It will be the advancement. So these are the designing and implementation part, and in which basically the two section is there. First is the blue, shown by the sky blue shade, in which the Raspberry Pi is connected with the power supply, and Raspberry Pi further connected with the USB camera as well as LCD display and the user's thing speaker. So with the Raspberry Pi given to the data to the ThinkSpeak app, and the data, we can extract the data, or we can find out the data with over ThinkSpeak platform. And in the lower portion, pink shows that the battery is connected with the speed controller mechanism and conveyor belt we can control. The proposed framework of the system is input. Input will be the data which is captured by the camera, and after pre-processing object detection, and data will be divided into two parts. The first one is the data uploaded to the ThinkSpeak through the IoT, and second one is object classification. So data will be directed to the, depending upon the data is required size or not required size. If not required size, so this process will be further in the process. And this one is the result and the discussion section, in which this figure basically show. In first figure, basically just to show the tripod stand and camera is basically shown. In this one is the camera, and this one is the tripod stand, and this one is the conveyor belt, which is designed by us in the laboratory, and in second manner. And in this section, we can see that the figure above depicts the back end of the system, where the size classification takes place using a Raspberry Pi and OpenCV library. These images show the implementation of the sorting feature, which is an important aspect of the project. And on the left, present a case that is deemed not required. So this one is the Raspberry Pi. This one is the Raspberry Pi, and this is the actual the object which is conveyed through the conveyor belt. So here we are using the nut So and the different type of the net. So it's exactly show the manually we have observed the shape of the area of the nut, and after after using the conveyor belt. Ratio is very little bit difference, otherwise accuracy is more than 95%. And this one is the figure present the LCD display which show the calculated area by the Raspberry Pi, and the display serve as the interface for the user, providing relevant information and the facilitating interaction with the system. So exactly the area is 1.3 centimeter square. So this one is the particular area 1.3 centimeter square. And the integration of IoT in an automatic conveyor belt system has significantly enhanced its functionality and the capabilities. In addition to the object detection and size classification process, the system seamlessly uploads the relevant data to the ThinkSpeed platform. So basically, if the data is on the ThinkSpeed, so we can observe remotely, we can control the speed as well as with the help of IoT platform. That's why we are using the Raspberry Pi to control the whole process. And display unit is there in the front of the technician, which will be handle the conveyor belt. So directly we can observe the in text mode as well as in the remotely we can access the. So this one is the graphically representation. The accuracy of the object area calculation was evaluated using the test dataset, and the results are depicted in the graph. So basically, we have observed the data, and that data is sorting in a particular manner. That's like, and after that, the graphically representation is there. So expected area, output area, and accuracy. So we can observe that our accuracy is 96.46. Sir. Just a minute, sir. Just a minute. This is the conclusion part. The contour detection algorithm was able to process images from USB camera and identify the contour area of the object passing through the region of the interest. The system was able to accurately calculate the area of the object. The LCD attached display the area accurately. The DC gear motor controlled by the pulse width modulated speed control is successfully in varying the speed of the conveyor belt system and provide us with an enhanced control of the system. The integration of IoT was further enhanced. The automated conveyor belt system capabilities allowing for real-time data access and remotely monitoring. So this one is the basically the actual meaning that we can remotely access the data, and we have displayed as well as the data in the LCD display. And the accurate objective detection, size classification, IoT integration collectively contribute to an efficient and reliable object sorting solution. So this basically this paper outcome determines the successful implementation of IoT integration, offering user a comprehensive and advanced system for the sorting need. So these are some future scope which we have observed after doing that work. Is sensitivity to lighting conditions means that the accuracy of the object area calculation can be affected by the intensity and consistency of the lighting condition. Means that if we are observing in the particular contour area, if there is some source of the energy or lighting from the other sources, in that case, if the exact contour will not find out, in that case, there will be some position or some part to introduce in some noise in the condition, or it will not the exact 100% efficiency will be there. So there will be some possibility to affected by the actual results. So variation in brightness or shadow will also play an important role and may introduce error in the detector contour area. Furthermore, advancement to handle different lighting scenarios or incorporate additional images processing to reduce the impact of. There are only the pre-processing techniques to reduce the impact of the lighting variations of the area measurement. Frame size variation and contour area accuracy. Change in the frame size caused by the different aspect ratio of the USB camera on the conveyor belt can influence the accuracy of the contour area calculation. And object occlusions and regular shapes. Objects that overlap or have irregular shape cause changes for the contour area detection. Overlapping object may result in merged or distorted contours. That's why if there are some possibility to suppose that there are 2 or 3 things is there, and in combined form if passing through the over the conveyor belt, so there are sometimes it will not exactly overall contour will be find out, but no, it will find and say about what is the 3 components which is conveyor, and we can find out the exact the shape of the each. So this one is a problem. That's why we have to do some work on that. It will be show the exact data. And threshold and parameter selection is very important part. So we have to work on these parameters and enhancing sorting algorithm. And in summary, the future scope of this research lies further improving the sorting algorithm, incorporating machine learning techniques. If the machine learning techniques is so strong, that's why we can compare the data with existing in very short period, and we can understand that our data is in the accurate process, or it has
Mr.
to be some
Devraj,
document.
you are out of your time. Okay, already have
These are
taken
some
so much time. So
references parts, sir.
kindly tell me,
Yes, sir.
tell me one thing. Have you utilized this uh, in this project? Have you utilized this sorting of different type of objects, or only size classification you done?
Sir, right now it's only the sorting is not there. Only the we have find out the area, particular area of a object.
So it means you utilize only camera.
Yes, sir.
No other sensor is utilized. Okay.
Yes, sir.
So it means there is no IoT.
No, sir. Actually, we are We are sorting. We are sorting the what we have find out the particular area, and that area will be given to the remotely. So with the help of IoT, we have convey the exact data to the
IoT is utilized in camera, you can say, but no IoT based sensor is utilized.
Yes, sir.
No other sensor for distance sensor or some other or color based sensor. Have you utilized any sensor in your overall work?
Sir, basically, contour area is there, and Raspberry Pi we are using, and with the internet, through internet we are sending the data, and we are also using the control unit in the speed control of the motor. If as per requirement, we can control the.
So currently, you are working on this project, or it is completed?
Sir, we have done till which I have shown, that one we have done, and further we are under the process. Work is on going on, sir.
Okay.
Yes,
Okay,
sir.
that's it from my side.
Yes, sir. Thank you so much, sir.
Thank you, sir. Next paper ID 408, discrete time realization of fractional order proportional integral controller for first order plus time delay plant by Bhanita Adhikari.
Hello, ma'am. Hello, ma'am.
Yes, your voice is audible.
Okay, ma'am. Is the slides okay? Is it visible?
Yes, sir.
Okay. Okay, thank you, ma'am. Good afternoon, respected session chairman, the delegates, and all the presenters present in the 5th International Conference on Recent Development in Control, Automation, and Power Engineering, in short, RDCPAE. My name is Bhanita Adhikari, and I shall be presenting the paper ID 408 titled Discrete Time Realization of Fraction Order Proportional Integral Controller for First Order Plus Time Delay Plan. The presentation is structured in the following manner: the introduction, then the design methodology of the FOPI controller, followed by simulations and result, and finally the conclusions and the references. So starting with the brief introduction, the physical phenomena of exhibit complex behavior, which requires a flexible and comprehensive modeling framework. And the non-integer calculus or the fractional order calculus has emerged as a powerful tool to accurately describe the physical phenomena. Its applications can be found in various fields of applied mathematics, then engineering sciences, control systems, and so on. In control theory, for the first time, Udlabni proposed a generalized form of PID controller which possesses additional fractional order power terms. There are several analytical methods to tune a fractional order controller. In this work, we have used a frequency domain technique, which is a frequency trained approach that aims at achieving a flat phase by considering four design specifications. However, the fractional order controllers are infinite dimensional due to the presence of fractional power term s to the power beta. So proper approximation is necessary. Also, there are several continuous time domain approximation techniques, amongst which the outer loop approximation is the popular one. And additionally, for digital execution, discrete time approximation is very essential. And discretization rules are basically the S to Z domain mapping relationships. In this work, LLRE operator has been employed, which is a linear amalgamation of testing and Euler rule. To this aim, we have three objectives. First is to tune a fraction order proportional integral controller for a class of first order plus time delay plant. Second, to employ the rational approximation in continuous time domain. And then we apply the discretization rule to its approximate model. And finally, to analyze the impact of the control design scheme with the help of simulation results. So talking about the design methodology of the FOPI controller, first we have considered a first order plus time delay plan with time delay 0.001 seconds, which is given by T of S. The transfer function of the FOPI controller has been given by C of S, where Kp is the proportional gain, I is the proportional integral, integral gain, then beta is a fractional term, and these three are the unknown parameters which needs to be determined. On connecting the plant with the fractional order controller, we obtain the open loop transfer function, which is given by G of S as shown in equation number 3. The plant model requires to fulfill certain design criteria, and for this case, we are considering 4 design specifications. First is the gain crossover frequency criterion, where the magnitude of the open loop transfer function at gain crossover frequency is equal to 1. Second, the phase margin criteria, where the phase of the open loop transfer function at gain crossover frequency is equal to minus pi plus pi n, where pi n is the phase margin. Third, the gain margin criteria, where the magnitude of the open loop transfer function, but at the phase crossover frequency is equal to 10 to the power modulus of Gm by 20, where Gm is the gain margin. And fourth, the phase crossover frequency criterion, where the phase of the open loop transfer function at phase crossover frequency is equal to pi. For tuning the FOPI controller, we have used the loop shaping method, which is the frequency frame approach. And from the equations 4 and 5, we have derived simpler expressions of the controller parameters Kp and Ki, but with respect to the gain crossover frequency and its related phase margin, which is shown in equation 8 and 9. Similarly, another set of expressions for Kp and Ki are obtained, but with respect to the phase crossover frequency and its desired gain margin. Now, on equating equations 8 and this equation 8 and equation 10, we have obtained a curve which shows the relationship between the fraction of the term beta and the 10 to the power modulus Gm by 20. Similarly, another set of expressions can be obtained, or a curve can be obtained by equating equation number 9 and 11. On plotting both the curves, we obtain the value of beta graphically, and which will be given by the point of intersection. With the help of this point of intersection, we can determine the other values like Kp and the Ki. And once the continuous time FOPI controller is designed, we shall apply Austerloo approximation technique, and the nth order Austerloo approximation for the frequency band of omega b to omega h is given by equation number 12. This equation shows the provides us the integer order transfer function of the s to the power beta term. Thereafter, we apply the discrete time realization, which is done using the LLRE operator. And for a sampling time delta, we have the relationship as shown in equation number 30. This shows the S to Z domain mapping relationship. Now talking about the simulations and results, we have considered the gain crossover frequency to be a 10-degree radian per second, then phase crossover frequency to be 150 radian per second, and phi m to be 60 degree. Now, on substituting these values to the related equations and plotting the two curves, we see that the point of intersection is 0.8706, which is the beta value, and this value with this value we compute and determine the value of Kp and Ki as 2.7086 and 19.37 respectively. Now, connecting this section of the controller to the plant, we obtain the continuous time open loop transfer function as shown in equation number 15. Now, we see that in equation number 15, there is a fraction order term which is s to the power 0.8706, which needs to be approximated, and we apply a fifth order Auster loop approximation for that. And we have considered the frequency band of 0.0012 to 1000 radian per second. And equation number 16 gives us the integer order transfer function for s to the power beta. Using this expression, we are obtaining the rational order approximated OLTF. Now, if we see in figure 2, we have plotted the ideal response, which is a solid line, and the approximated response, the continuous approximated response, that is the dotted lines. And from here, we see that it is very prominent from the Bode diagram that our gain crossover frequency of 10 radian per second, then a phase margin of 60 degree, and phase crossover frequency of 150 radian per second, and a gain margin of 26.7 dB has been attained. This illustrates that the integer order approximation has been successfully carried out. And here we see that this four forms the vertex of a rectangular frame, and thereby it gets its name, the frequency frame method. Now we have applied the LLRE operator for a sampling time of 0.007 seconds, and the discretized integer order transfer function of s to the power 0.8706 has been given in this equation 18, and its corresponding discretized OLTF has been given by GD of Z, which is shown in equation number 19. Now, in figure 3, we have plotted the ideal system along with the discretized LLRE approximated system, and we have seen that for the mid-frequency range, both the magnitude as well as the phase characteristics or response are ideally resembling. It is resembling the ideal system, though there is some variations or there is some deviations from the ideal this at the extreme corners, and also a flat phase can be seen around the gain crossover frequency, which is 10 radian per second. Then 4 is to study the effectiveness of this controller or design or to establish the robustness condition. What we have done is we have varied the plant gain up to 700%, and we have seen that there is no phase change in the phase characteristics, and also a flat phase can be seen or exists, and thus we can say that it verifies the robust nature of the controller design. So I would like to conclude by saying that a discrete FOPI controller has been successfully realized for a for a first order plus time delay plan by successfully fulfilling the 4 design specifications. Then the Auster loop approximation has been applied, which then undergoes the discrete time realization using the LLRE operator, and the result shows that in the mid-frequency range there is a resemblance with the ideal system. Also, by varying the plant gain, we see there is no change in the phase characteristics, and also flat phase is very prevalent, and which indicates the robust nature. Here are the 18 references. With this, thank you so much for your time. Any questions?
Thank you. I have one question. Like, can you say some more applications of this controller and some other applications?
Other applications of like controls
Yes,
professional
configurations which you have developed.
Okay, ma'am, the one I have considered for the plant model is the first order plus time delay plant model. So we can see that it is like more dynamic in nature, and its applications can be seen in like chemical processes, where distillation processes. Then you can say like industrial, like temperature control type, then pressure control. So, ma'am,
Yes.
yes, ma'am.
Okay. Thank you so much.
Thank you, ma'am.
Next paper ID 142, Smooth Imaging System using Learning Generative Adversarial Network by Shipra Saraswat. Shipra, are you there? Please reply, ma'am. Shipra. Yeah, okay. Ma'am, please reply.
Shipra ma'am, are we able to hear you? I mean, you are able to hear us? Hello, ma'am.
Ma'am, because we're not able to hear you, we're concluding the session. So, ma'am, please could you respond? Ma'am, message to किया है. नीचे से message आया है.
Yes, I am here.
Please, ma'am, could you present your paper?
Ma'am, please present
Allow
your
me to
paper.
audio now. Audio, it's on.
Ma'am, please unmute yourself. हो गया. Ma'am, please start. No, ma'am, you are not audible.
Ma'am, we will send the questions from the examiner in chat box. You can answer in that. I think there is some issue with that voice, so we can continue like that only. Ma'am, please try to share your presentation again. So you can just share your PPT. she will write down in the chat box. नहीं हमने आपका enable कर दिया. Not visible right now. Let's get it once again. Yes, yes, yes. कोई issue नहीं है मैम, आप इसको post कर दो. You just move on the slide, and if examiner wants to ask, and I think you can move on to the result. Is it? ठीक है मैम, मैं स्पीकर पे रखती हूँ. बट मैम मुझे दूसरा सेशन भी स्टार्ट करना था, आप जल्दी आप कंक्लूड करिएगा. Okay, ma'am, please speak.
Yes. Respected session chair, sir. Very good afternoon to everyone, my dear faculties and students. I'm Dr. Shipra Saraswat, Associate Professor in Amity University, Noida, SFCSC. My paper title is today is Smooth Imaging System Using Learning Generative Adversarial Network. Okay, I'll come on to the directly my result section. In this proposed model and work, we apply the architecture of the generative adversarial network and we given the real world images to the generator and the output of the generator is the input of the discriminator. And by this way, we can basically blur images into the deblur images. And this is the result analysis. This is the figure showing blurred image from left to right. In the middle image, the blurred image and the target one is at the last. So by this proposed model, when we given the input of the images to the generator, we used the generative adversarial network because it is the best to enhance the quality of the blurred images into the deep blurred. So while doing this, we have the two types of losses, the perceptual loss and the water loss. The perceptual loss and the water stream loss, perceptual loss, we have the difference between the high-level features of the two images we calculate, typically extracted from a peak-end convolutional neural network. And in the water stream loss, it is also a loss function that repeatedly is the gap between the scores from the real and the produced imagery. It takes the mean of the differences between the two images. So it's increasingly regular. So this is the permanent loss. So at this result analysis section, we basically taken the two student convolutional blocks, two transposed convolutional blocks and the 9 residual blocks. The instant norm layer and the leaky layer we use, and the value of the alpha is 0.2, then we do the coding in the Caros Python, and we calculate the peak value of the signal to noise ratio and the similarity structural index. So we got these two values and we successfully understand how today's generative adversarial network are trained by tracing the weight of the discriminator while training the generator, and two losses are combined while compiling the model. So basically we successfully calculate the peak value of signal to noise ratio and SSIM, and this model successfully deblurs the image without loss of context and the contrast. So this is all about my work. This is a conclusion. The system is capable of deblurring the images. It takes the image and passes to the convolutional neural network to deblur the image by using the generative adversarial network. So these are the latest references, 2023, which I used. So this is all about.
Ma'am, I hope you can hear me. I have one question. Ma'am, so have you tried with the images which are also taken from different angles or different positions, or they are the same kind of images? So what is the kind of input you have taken?
Basically, we take the database. No, we didn't did these type of the rotated images and from the different angles. This is our future work, which we can use, this is our future scope which we try to implement and extend this paper for any focus index journal. The images as input, normal blurred images, and apply the scan and de-blur the images.
Okay, ma'am. Thank you so much.
Okay. Okay, ma'am. Thank you so much, session chair.
Thank you, ma'am.
Thank you, session chairs, for your valuable contribution and leadership in this session.
An important announcement, all presenters will receive their certificate via email after the conclusion of RDCPAE 2023. I extend my heartfelt gratitude to all of you for your valuable participation. Thank you. The participants can now leave the session.